Hey guys, this is Sam with Nexus Workshop. We're going to be looking at the Nexus Ultimate Prop Controller. But today I got asked to do a little demo of how you can set up like an A-B type puzzle situation where it physically has pieces that move into place into the solve, but then we want to, without having to reset it, let it get solved again with a different solution. And so an example of this was the pirate chest that we had at Transworld, where it's a pirate chest. It's got colored Cryptex wheels on the top, and so you put them into the right colors, and that's a solve, but then it stays there, and the rest of the game progresses on. And then when another set of players comes back through, it is actually able to target a different color pattern so that the one that it's on was the solution for A, but now it has to get changed to a different combo, different set of colors for B, and that's what solves that again. And so it keeps alternating back and forth between those. That way you never have to do a physical reset of it. In here, I've got my prop controller hooked up. It's got my color sensors and all of that. This video is not going to go over that. I have another video that goes over specifically the color sensors use the level inputs feature. They're analog inputs, so they have a range that maps to colors. But in here, this is just kind of as streamlined as I could get it. We have states, and so typically the way we always do it is I've got a ready state and a solved state, and then my solve state is going to wait 3 seconds and then go back to my ready state. So nice and easy. I'm ready, I'm armed, I solve, I stay there for 3 seconds, and I reset myself ready to go automatically. The thing that I have that's a little different is a variable. I have this variable that I've called last solved. I don't have anything set for a startup value, and you'll see why in a second, but I have it set as last solved. And so what's going to happen is in here on the behavior tab, I look at my logic rules and I have solve A and solve B. That's my two solutions. Solve A looks here and it says, cool, all these color sensors need to be these specific colors. So each of those color sensors maps to a color. Awesome. But then it also says, hey, variable last solved has to not equal A. Which means when we solve a puzzle, we say, hey, I solved solution A. It sets that variable to A, and as long as that's the last one that happened, it won't let this trigger again. Instead, it would force B to happen. And that's how solve B looks. Exact same thing, different set of colors, and then it says that last solved cannot equal B. The reason I use not equal itself instead of equal the other is that when we boot, I don't have to worry about what the startup was or if it gets out of sync or anything like that. All it cares is that while it's sitting on its solution, it can only fire once. In here in action triggers, those logic rules don't do anything. All they do is fire these action triggers. And so my action triggers, I have solve A, which goes off of logic rule solve A, and it sets the variable, says, hey, the last solved was A, and then it sets the state into solved. Solve B does the same thing, except it triggers off logic rule B. It says, hey, the last variable, the last solved was B, sets the state to solved. And then whenever I enter the solved state, I turn my relay on, and when I enter my ready state, I turn the relay off. I could also do that based off the solved and on exit, but it's kind of either one. And that's it. Nice and super straightforward. I could do other things, like I could be setting that last solved via a network trigger. I could have something else that actually does the rearm or handles that. Instead of having it, my variable being tracking what's last solved, I could have it track what's the target. And so I could use that if I was maybe doing not necessarily directly an A, B, but maybe I'm doing difficulties. And so I want to have multiple different solves, and like what they did on prop A does something, and depending on that solution that they put into prop A or those things or what they brought to it, they brought this statue onto the pedestal, and because of that, the solution for this puzzle is going to change. And now, they're going down these branching paths or anything like that. And so that is how I would do it. How I'd accomplish it is by creating this like target, and if the target equals, just do a separate logic rule for each of them. That's obviously a pretty straightforward and simple way of looking at it. Is I have just these state machines and I'm just choosing which one of them is valid right now. It's basically the same thing as if I was to do a multiple stage puzzle where I say they have to solve A, then they solve B, then they solve C. Same thing. I kind of have my what state am I in, or what is my variable set to for where's my target, and then I use that in my logic rule to solve my puzzle.